So we have first in statistics, we have mean, median, mode calculations, then range, standard deviation calculation. Okay, so these are all measures of central tendency. These are all measures of central tendency. These two are measures of dispersion. That is, in the set of values, how all the values have clubbed together towards the central value. That is called a central tendency. That is expressed by mean, median, and mode. And this is the range, how the values are dispersed, are variable, or one variable is varying with each other. So that is called as range and standard deviation. So it is given by the formula mean is otherwise called as average. So which is equal to sum of all observations divided by total number of observations. That is your mean. Median is the central value. It is otherwise called as the central value. So you have to assign all the list of values or arrange the values in either ascending order or in the descending order. Then you have to find the middle value. If the total number of values are in odd number, then it will be easy. Suppose, for example, 5 values are there, third value will be the middle value. So to calculate that, you have n plus 1 by 2 value is called as median. So if you have 10 numbers, that is even number of values, then you have to calculate the average between 5th and the 6th value. So that is the median. Mode is most number of repeated observations. Mode is otherwise called as repeated value. So these three are the measures of central tendency, measures of central tendency, and measures of dispersion. We have range, which is given by the formula maximum value minus minimum value. So this indicates how the values are spread from the one end to the other end. So this is called range. Then we have standard deviation. Standard deviation is given by the formula root of sigma x minus x bar the whole square divided by n minus 1. This n minus 1 is there if the values are less than 30 samples. If it is more than 30 samples, then you can just keep it as n instead of n minus 1. So the formula is given by x minus x bar. So whenever it questions x bar is nothing but your mean. So mean is otherwise called as x bar. So here in standard deviation, we have to calculate. We have to put a table. We have to put the first serial number. If suppose we have 5 values means, we have to put up serial numbers like this. Then the particular value. Suppose we have 3, 4, 5, 7, 8 like that means. Then we have to calculate the average. That is mean. Then we have to calculate x minus x bar. Then x minus x bar the whole square. Then we have to sum of it. This will give sigma x minus x bar the whole square. When you divide it by 5, this is called as variance. This is called as variance. And when you take the square root of variance, it will give standard deviation. Now from this we can calculate some more. That is standard error. Standard error is given by the formula standard deviation divided by root of n. That's ST is called a standard deviation and root of n is the sample size. So from this is the standard error of mean. This is standard error of mean. When you are calculating confidence interval, which is nothing but mean plus or minus 2 standard error. So you will calculate standard deviation. From here you will calculate standard error. From here you will derive this confidence interval. That is nothing but mean plus or minus 2 standard error. Then you can calculate coefficient of variation. Coefficient of variation. That is given by the formula standard deviation divided by mean into 100. Coefficient of variation is expressed in percentage. Standard deviation by mean into 100. You can derive mean deviation, that is sigma x minus x bar divided by n, that is called as the mean deviation. Now the second problem is about the tests of significance. So tests of significance. Test of significance. The commonly used test of significance is chi-square test. So we have 4 steps in this, defining the hypothesis. Then second is calculation of chi-square value. Third is calculation of degree of freedom. Fourth is finding the probability values. So we have these 4 important steps in the calculation of chi-square test. So why chi-square test is needed is to prove the association. So we have to see whether the association is real or not. So that we will prove at the end of the test. If the p-value is less than 0.05, then we call it as significant. So for that, we need to say the hypothesis. Which 2 variables you are associating. Usually, you have to define the alternate hypothesis and the null hypothesis. Alternate hypothesis always says there is some association. There is association. Whereas your null hypothesis says there is no association. Null means nothing. So there is no association. Lung cancer, you have patients like this. Smoking, you have like this. You randomly get patients like this with 50, 20, 30, 40. There. So you want to say if there is association, that is your alternate hypothesis. If there is no association, then that is called as null hypothesis. So you have to mention what is your hypothesis. That is the first step in chi-square test. The second step is calculating the chi-square value. Chi-square value is given by the formula sigma observed minus expected the whole square divided by expected. So like how we put a table for standard deviation, we have to put a table here also. We have to assume this is A, B, C, D. So A, B, C, D. So what is this observed value and expected value? Observed value is just what you got. Expected value, if there is no difference, what would have been the value there? So that is calculated usually by row total into column total divided by grand total. So expected formula for expected value is row total into column total divided by grand total. So we have to calculate expected values for all these cells. So for example, in this case it will be, for example in this case A will be 90 into 80 divided by 140. Like that all the 4 values we have to calculate. Then we have to put the observed value. Then observed minus expected. Observed minus expected the whole square. Then observed minus expected the whole square divided by E. Sum in observed minus expected whole square divided by E. This value is called as your chi-square value. This is the second step in chi-square test. Then third step is degree of freedom. What is degree of freedom is, if you have these cell values already prefixed, only one value put up here will automatically fill all the values here. So this is calculated by the formula row minus 1 into column minus 1. So we have 2 rows here, 2 minus 1 into column minus 1. So row degree of freedom here is 1. So in exams, most commonly you will get only 2 bar to table. So that degree of freedom will be 1. If in case it is 3 bar 3 means then it will be 4. 3 bar 2 means 3 minus 1 into 2 minus 1, which will give 2. Degree of freedom will be 2. So here most commonly in your exams you will get 1. Then after getting this calculating this degree of freedom and getting this chi-square value, we have to look at the probability table for the p-value. But sometimes this table may be provided. But most commonly when 2 bar 2 table is given for you, we may not provide probability table. So you have to memorize this number of 3.84. When the chi-square value is greater than 3.84 for degree of freedom 1, then p-value will be less than 0.05. This you have to remember this number. For p-value for degree of freedom 1, when the chi-square value is greater than 3.84 or otherwise in any 2 bar 2 table, you get chi-square value greater than 3.84, then the p-value is going to be less than 0.05. P-value less than 0.05 indicates that there is a significant association between your thing. So in that case, if p-value is less than 0.05, then you reject null hypothesis. If p-value is less than 0.05, reject null hypothesis. If greater than 0.05, then accept null hypothesis. So this is the first test of significance we use, that is the chi-square test. Then we are moving into standard error of mean and standard error of proportion calculation. Now the third problem, which is the standard error of difference between proportion and mean. Between proportion and mean. Example here is hemoglobin level among boys is 10 grams, girls is 9 grams. So this is the mean hemoglobin level among boys and girls. Then the question here is, hypothesis here is this difference significantly different or not? Same way, the proportion means the percentage of or prevalence of anemia among boys is 13%. Girls it is 15%. There is a difference of 2%. Is this 2% significant or not? So this is our research question. So based on this, we have to formulate the hypothesis first, as we did in chi-square test. So now this is our hypothesis. From this, we are going to calculate a z value, which is given by the formula actual difference divided by the standard error of difference between two means. Means are proportions. So now I am just going to focus only on proportions, just to deal with one at a time. So in this case, you can find out the actual difference easily as 2. So you can just substitute the actual difference between the mean hemoglobin of these two things. What you need to calculate is standard error of difference between proportions. This is given by the formula. Standard error of difference between the two means is given by the formula. For proportions, it is given as root of P1, that is prevalence in the first group, Q1 divided by N1 plus P2 into Q2 divided by N2. So this is the formula. So here I have not mentioned about what is Q. P is your prevalence. In this case, it will be 13%, whereas Q is 100 minus P, which will be 87. Whereas number of boys will be here the N1. The same way you will write it for Q2 here for girls. Then you calculate a particular value. Then and again substitute here. Then you calculate a particular z value. Like how we said in chi-square, 3.84 is a magical number. Here, the magical number is 1.96. If the number is more than 1.96, if the number is more than 1.96, then you say there is a significant difference. That is, p value will be less than 0.05. So this is for the proportion. For the means, what is the difference here is, for the means, instead of P1 prevalence and P1, you substitute the formula with standard deviation of the first this thing. Here, the standard deviation of the second this thing. You calculate the same way. Calculate this because P1 and P1 we multiply here. It is a standard deviation square of 1 and standard deviation square of 2. So then you calculate the value of standard error of difference between the two means. Then substitute here. Then you calculate the p value. The magical number here is 1.96 for difference between two means. So that this thing you have to memorize. This number you have to remember. So that is about the third problem. Significant standard error of difference between two means or proportions. Now the fourth one is about chlorination of well. About chlorination of well. Here we have three important steps. One is the calculation of volume of the water level. Two is your amount of bleaching powder needed. Fourth is the procedure to mix. This is full theory. So now the first step is calculation of water level. Chlorination of well is the calculation of the volume of the water level. Here the most important thing is you are calculating the volume of the water, not the volume of the well. So you have to be very careful in assessing the water level, not the entire volume of the well. So there are maybe three different types of wells. That is cylindrical, rectangular, and conical. Conical well will be very rare, but in case they ask, you have to answer. So cylindrical well is given by the formula pi r square h, where r is the radius, pi is equal to 22 by 7 or 3.14. Height is the height of the water level. Water level, not the well height. Then rectangular means length into breadth into height. Then conical means 1 by 3 pi r square h. So this is about the calculation of the volume of the water level. And the second step is amount of bleaching powder needed. So here we use the Horrocks apparatus, which consists of 6 cups, and we add 1 drop of the stock solution here, 2 drops, 3 drops, 4 drops, 5 drops, 6 drops. So if the third cup turns blue, which means you need 6 grams of bleaching powder to disinfect 455 liters of water. Here you can ask why it is 455. 455 is nothing but your 1 gallon. 1 gallon of water. So that is, you need, if the third cup of Horrocks apparatus turns the color, turns into blue color, then that indicates that only chlorine appears. So 6 grams of bleaching powder is needed to disinfect 455 liters of water. So this is the basic principle. So based on this, we need to calculate. So it is given by the formula amount of the bleaching powder. Here you need not worry about the percentage of the bleaching powder because Horrocks apparatus does not take into consideration. You are testing with the Horrocks apparatus with the bleaching powder and with the water. You are going to do the disinfection. So you don't want to worry about the percentage of chlorine which is present in the bleaching powder. So amount of bleaching powder added needed to disinfect is the volume of the water 2 into which cup, number of cup which is turning the color divided by 455. With this formula, you will get this thing. So in this calculation volume, you have to understand one thing. It will meter cube, which is equivalent to 1000 liters. So whenever you get these values, if you get in meter cube, you have to multiply it with 1000 liters. So when you substitute the volume here into 2 into suppose it is 3 means, then you will get the number of grams of bleaching powder needed to disinfect the water. This is the second step. Then the third step, as I said, it is going to be the theory. So what you should do is, you should take a bucket. 100 grams of bleaching powder cannot be added in the same bucket. So not more than 100 grams of bleaching powder. You have to put the bleaching powder, then put water, make it into a paste, then add water up to 2/3 of the bucket, then remove this alum, this your lime. So bleaching powder is nothing but chlorinated lime, that is CaO.Cl2. So you have to remove the CaO. If you don't remove the CaO, when it goes into the well, it will again combine and form bleaching powder. It will not liberate free chlorine. So for that, this is the steps. These are all the steps. So you need to paste and remove this lime. Remove this lime, and only the supernatant solution should be added. You have to tie it to a rope, insert it to the middle, agitate it vertically, horizontally. Then you have to ask the people to wait for 1 hour. So this is the time required for the action of chlorine to happen. Then only you can ask the people to start consuming the water for drinking purposes. So if suppose I said it is 100 grams, so if your total to the sea is 200 grams means, then you have to do it twice. The same procedure twice, and ask the person to wait for 1 hour, then they can consume the water. Now the fifth problem is about 2/2 tables or contingency table we say. So with the 2/2 table we have 3 different kinds of problems. One is for case control studies, one is for cohort studies. Here screening calculations, that is your diagnostic test calculations. So in 2/2 table we have 2 important rules. That is, always disease should be on the top. The exposure should be on the column side. Second rule is, always think positively first. So we have to put positive first, negative second, positive first, negative second. So I have mentioned 2 rules, that is, disease should be on the top and column should be filled with the exposure. Exposure here, outcome there. So this is the basic law for a 2/2 table in case control study. So if you can make this table perfectly, then half of the calculations are done. So here we get particular values A, B, C, D. We say in case control study, you can calculate odds ratio. Odds is nothing but your chance of disease. So odds is given by the odds ratio is given by the formula AD by BC. So AD by BC is otherwise called as cross product ratio. Cross product ratio, that is the cross product ratio AD by BC. So with this, 75% of the problem is over. Then what is the best 25% is, you have to write the interpretation properly. So here in interpretation, the only difference between case control study and cohort study is the similar measure what you get there is relative risk. What relative risk say is, if suppose you smoke, you have 8 times more chance of getting a lung cancer. But in odds ratio, you say among lung cancer patients, being a smoker will be 8 times more. So it is a retrospective study. So we have to be very careful in that interpretation. So that is about case control study. Then second is your cohort study. The same rule applies there also. This is the outcome should be on the top. Exposure should be here. Always be positive. So you have values like this A, B, C. What you can calculate is incidence. That is incidence among the exposed. These are all the exposed group. Here you can calculate that this is the exposed group. Incidence among the exposed is A by A plus B. Incidence among exposed. Incidence among unexposed is C by C plus D. This is incidence. Now, relative risk is given by the formula incidence among exposed divided by incidence among unexposed. So the interpretation again here is for a smoker and lung cancer, being a smoker 8 times, if the relative risk is 8, then you have to say being a smoker is 8 times more chance of for getting a lung cancer. So that is the relative risk interpretation. Then we can calculate two more values here, that is attributable risk and population attributable risk. The basic difference here is population attributable risk is if suppose I remove smoking from this community, how much amount of lung cancer can be prevented? Attributable risk is how much amount of lung cancer is directly attributed to smoking. So that is it is given by the formula incidence among exposed divided by incidence among unexposed divided by incidence among exposed. For population attributable risk, it is given by the formula incidence among the total population minus incidence among unexposed divided by incidence among the population. So all these three relative risk, attributable risk, population risk and its interpretation we have seen. Then the last one is your screening. Screening, as I said, this is here it is not the outcome here. You have to mention it is gold standard. Gold standard. Then the test, whatever the test says or not. So positive, negative. This is called as true positive. The test says positive. Actually, this is true positive, this is true negative, this is falsely positive, this is falsely negative. Now, you can calculate 4 values from here. One is sensitivity, specificity, positive predictive value, negative predictive value. So how to remember this formula is very simple. From here A, B, C D, but in book it has given us A, B, C, D. I am not using here the formula because it will be good for you to remember the formulas. For predictive value, if it is positive predictive values, all P's will be there. Positive predictive value, all P's. There are 2 P's here, TP and FP, TP by FP. Negative predictive value means all negatives will be there. In all these formulas, true will be on the top. Always remember, truth will be on the top. So all these 4 formulas, truth will be on the top. So this is given by the formula. So what it means is, negative predictive value is out of the totally predicted negative, how many are truly negative? Out of the totally predicted positive, how many are truly positive? That is the predictive values of positives and negatives. Then we have specificity and sensitivity. Sensitivity, you have to remember in this way, positivity among disease. Sensitivity is positivity among disease. Specificity is negativity among healthy. If you remember this phrase properly, sensitivity is positivity among disease, specificity is negativity among healthy. So, who are positives? I said true will be always on the top, here true or negative will be on the top. So positivity plus false negative. These are all the proving the disease. This is true negative plus false positive. As I said here, it will be exactly the same. For positive predictive value, all P's will be here. For negative predictive values, all N's will be here. Here, if it is positively among disease, you can easily do this, and it will be the exact opposite of this. This two will be the exact opposite. So this is the sensitivity and specificity. A test which is good, has good sensitivity is used as the screening test. A test which has good specificity is used as the confirmatory test. So here, the fourth letter is the key here. You can remember this way. Sensitivity means this is for screening. Fourth letter is the liquidity here. Specificity, fourth letter is confirmatory. So in your interpretation, if you have values of screening sensitivity and specificity, then you can mention whether it can be, the test can be used as a confirmatory test or a screening test easily. Sixth group, indicators. Indicators you can divide into morbidity, mortality. This mortality followed by fertility and MCH care indicators, maternal child care indicators. Then malaria and malaria indicators. These are just formulas. You have to know the definition of that particular word, then express it in percentage or thousand or lakh, that you have to understand. So morbidity we can divide it into incidence and prevalence. This will be again, it will be called as rate. So whenever you mention rate, you have to mention the period, specific time, what time it is. Under incidence rate, the commonly used are incidence, attack rates, secondary attack rate. Secondary attack rate. Incidence is given by the formula total number of new cases divided by total population, or the population at risk. You can say total population into 100, usually expressed in percentage. Sometimes it will be in thousands. If the incidence is very less, in decimals, less than 1, they mention it per 1000 or per 10% population. But whatever it is, you have to mention the incidence rate per 1000 population in that year. So there are three important components, not only this value, but also the other two are 1000, that is 1000 population, and per year, that is also very important. Then you have attack rate. Attack rate is same as your incidence. Only thing is, in the denominator, here the total number of cases. Only the thing is, this total population during epidemics, outbreaks, that is during outbreaks, risk, population risk. These two are the important thing in the attack rate. Then secondary attack rate is total number of new cases divided by total population at risk within one incubation period. Within one incubation period. This is called secondary attack rate. This secondary attack rate, as the secondary attack rate increases, the infectivity of the disease increases. As for example, chickenpox, measles, and all, we have about 85 to 90% of secondary attack rate, which means overexposed to that particular disease will get the disease. That is 85% chance of time the person will get the disease. That is the secondary attack rate. These are all incidence rates. And prevalence rate we have period prevalence and point prevalence. Period throughout the year, this is 2018 means January to December, some would have been suffered with tuberculosis recovered. New cases will come and go. So if you map all these things and measure, that is called as period prevalence. And if you at a particular point of time in the month of October, how many cases are there? This is called as point prevalence. Whereas the cases which is present between January and December will be considered as period prevalence. Prevalence also will be commonly expressed in percentage, which means your denominator is per 100 population. And diseases like HIV and very rare diseases and all, you can express in per 1000 population or 10,000 and so on. So that is about your mortality indicators. And coming to the mortality indicators, we have the common, the first and foremost is your crude death rate. It is called crude death rate because, like your crude oil, you have to, it is comprising of all the diesel, petrol, like that. Crude, this is crude because it has total number of deaths. Total number of deaths divided by total population into 1000. So in this indicators, you should always mention about the population per 1000 population and the time. That is very important. So this is total number of deaths. If it is replaced with births, then that is called as crude birth rate. Crude birth rate is an indicator of fertility. What are the other indicators of mortality? You have age fatality rate, proportional mortality rate, cause-specific death rate. Cause-specific death rate, age-specific death rate, gender-specific death rate, and all is there. You have to be very careful about these indicators. Numerators and denominators. For case fatality rate, the denominator is total number of cases. Numerator is total number of deaths due to the disease. This secondary attack rate is called as the spreading power of the disease. That is the infective power, how fast this disease will spread. Whereas the CFR is called as killing power of the disease, which is out of so many cases, how many will die. So this is always expressed in 100. So which means a disease with 100% fatality means all the cases will die. The examples will be rabies, etc. So that is about the case fatality rate. So proportional mortality rate means out of the total, as the name indicates, it is called the proportional mortality rate. Out of the total number of deaths, how many are due to the particular disease? Which means total number of deaths due to the disease. So this means tuberculosis proportional mortality rate is in this area, out of 100 deaths, 10 deaths will be due to tuberculosis. So that is also expressed in 100. Then cause specific. Again, cause specific means here instead of total number of deaths, it will be total population. Total population at risk, death due to TB. Like that, if you have a particular age, deaths in that age divided by total number of people in that age is called as age specific. Gender specific is the total population in that age, in that gender, deaths in that gender. This is called as gender specific death rate. So these are all indicators of mortality. From here we are moving to indicators of fertility and also the MCH gap. So first and foremost is your CBM, that is crude birth rate. As the name indicates, it is crude. It is given by the formula total number of live births. Total number of live births divided by total number of total population.
Indian population and global population.
All this total population will be median population. Median population. So this is crude birth rate. To understand the other indicators of fertility and MCH care, you should understand what is meant by abortion, what is meant by stillbirth, what is meant by neonate, what is meant by infant. So in this picture, this is the picture given in part. This is the point of delivery. This is the point of delivery. If the child is alive at this point, then that will be considered as live birth. If the child dies any point of time, 28 weeks later, then that period is called as stillbirth rate. That deaths are called as stillbirth. How do we calculate this 28 weeks? We can ask the patients what is the height of we can measure the height of the baby. If it is 1000 grams and weight 1000 grams, height, if it is more than 33 centimeter, then we conclude this 28 weeks. And any death less than this 28 weeks will be considered as abortion. So abortion, this is called as abortion. This is called as stillbirth rate. So all the births at this point of time will be considered as live births. Then the children who does not celebrate their first birthday is called as infant mortality rate. That is, the deaths before 1 year of age, that will be called as infants. They are called as infants. Then within 1 month, they are called as neonates. 1 month, it is called as neonates. In 1 month, we have two categories, which is 1 week and second to fourth week. This is called as early neonatal period. This is called as late neonatal period. And this period, that is from after 1 month to 1 year, it is called as post-neonatal period. And you should not confuse between this late neonatal period and post-neonatal period. Sometimes they will give infant mortality, that is before 1 year. Early they will give, post they will give. They will ask you to calculate. So you can subscribe and calculate. Then the deaths within 5 years of age, this is called under 5 deaths. So roughly we can say about 75 to 85% of the under 5 deaths will happen within 1 year. Out of 75% to 80% of the deaths of infants will happen within 1 month of their life. And out of the neonatal deaths, 75 to 80% will always happen within 1 week of this death. So, for this formula, you have to understand the fact. When do you say the child has neonate infant under 5 like that? So here we can calculate abortion rate. All these indicators will have denominators as live birth, except for your stillbirth and perinatal mortality rate, which has both live births and stillbirths also. So all these indicators have denominators as live births and all these indicators are expressed in 1000 line words. Okay, so now whatever is possible here, we can put it in the code. So abortion rate is total number of abortion divided by total number of line words into 1000. Stillbirth rate, total number of stillbirths divided by, sorry, for abortion rate it is line words only. For stillbirth rate it is line words plus stillbirths into 1000. For perinatal mortality rate, why this perinatal mortality rate is important is because it takes into account of both the pediatric care which is given after 1 week of the delivery and the obstetric care which is given before the labor. So any change in this postnatal perinatal mortality rate indicates the healthcare delivery, how pediatric and obstetric departments are going. So this perinatal mortality rate covers this both. So here the numerator will be stillbirths plus early neonatal deaths divided by live births plus stillbirths into 1000. Then you can calculate early neonatal death rate, late neonatal death rate, neonatal death rate, infant mortality rate, under 5 mortality rate, all these things we have numerators as per the definition and live births into 1000. This thing. So whenever you write this thing, you have the answer you have to write 75 under 5 deaths per 1000 pound, per 1000 live births. Like this you have to write. So the opposite of 100 minus under 5 rate is called as child survival rate. Child survival rate is otherwise called as that is the reverse of under 5 mortality rate. So these are all the possible FCH care indicators. Now malaria and filariae indicators. So for malaria we have annual blood examination rate. ABER we say, that is annual blood examination rate. So out of the total population, how many blood examinations are done? This is called annual blood examination rate. This is expressed in percentage. You have one next indicator, that is slide positivity rate. For slide positivity rate, you have out of the total blood examined, how many are slide positives? Again, you express this in percentage. Now we have API, that is annual parasite incidence. Here we combine these two and we say out of the total population, how many are slide positive? This is expressed in 1000. So the cutoff for APA is given as 2. So based on this, the high-risk areas of malaria have been classified. So these three are very important. If you replace this slide positivity with false parameter, see, this positives will show all the malaria positives. If you look at only the false parameter, then that will become slide false parameter. If the same way, instead of slide positives, you put slide positives for falsiparum, then that will be called as annual falsiparum index. So this is about malaria. Now one more which is left out is the filariae. We have filaria endemicity rate. Filaria endemicity rate. Then filaria microfilaria rate. Then the last one, disease. Filaria disease rate. So these three are the important ones. So for here the denominator is for all these things total number of people examined. How many slight positives? That is your microfilaria rate. How many clinically symptomatic filaria present? That will be your filaria endemicity rate. Sorry, filaria disease rate. Combining these two, it will become filaria endemicity rate. So the disease rate means disease should be exhibited. Microfilaria means slight positive should be there. Filaria endemicity means both of these combined. And this is expressed in 100 and 1000. 100.
Percentage.
That is in percentage. So in all these indicators, if you mention the unit, you get your final number as X means you have to say per the 100 population, 1000 population in year. So whenever you mention this denominator and the time, then only it will be called as rate. Okay, now we have missed out one more important indicator called the maternal mortality ratio, the MMR, which is defined as the total number of maternal deaths divided by total number of live births. This is always it was previously expressed in 1000. Now it is for last 10-15 years it is expressed in 1 lakh. This thing. So whatever maternal mortality rate is mentioned, you have to say 150 maternal deaths per 1 lakh live births in that year, in year 2018, like the government. So what is maternal death here? Any death which have arisen due to the complications of pregnancy, delivery, and postpartum period within 42 days. This is defined as maternal death. This is called as maternal mortality ratio. Now then, what is maternal mortality rate? You replace it because maternal deaths are compared with live birth. It is called as ratio. You replace the total number of reproductive age group women. Age group women here it will become maternal mortality rate. So with this we are concluding this indicators. So in this class we have seen about 6 set of problems which will be commonly encountered. We have missed a few in this problems. That is your t-test. We have not covered about t-test, which in some colleges they may have their problem set. So you can add a t-test. Then they will give the water report to you, and they will ask you to infer how what are the modifications, what will you recommend. And that is I write here. T-test is missed. Then water quality interpretation is missed. Prescription of a diet for a normal woman, adult woman, pregnant woman, like that it will be there. That is missed. Then they will do an outbreak investigation outbreak situation, and what measures you can take. This and all will be given in epidemiological exercises. So you can read out this. This will be a more theory. There won't be any formulas in this. So you can read out this theory. Thank you.